Let me explain velocity, average velocity, and speeds in my own words. Suppose you ran a 100-meter race. What was your speed at the moment you crossed the finish line? You might say the answer is easy, like 10 miles per hour, 15 miles per hour. Then my next question is, how did you get this? How did you measure this value? So if you take a picture of yourself at the moment you cross the finish line, right? Just picture this, just close your eye, picture this. You are running, and then you cross the finish line. At that moment, I take a picture of you. What do you see? Well, based on the picture, you are motionless. So since you are motionless, you are not moving at that point. So you take a picture, right? Check out the picture. You are not moving at all at that point. You are motionless, right, in the picture. Okay, so you are motionless. Based on this piece of evidence, how do you measure your speed? You are not moving at all. You have one picture of yourself crossing the finish line. You are not moving at all. Then how do you know your speed? How do you measure it? So what is speed anyway? The best example to think about speed is check out the dashboard of your car. Do you drive? So it is okay even though if you don't drive. Just take a look at the dashboard of your car. So there are two rings, right? So the rings on the left shows the RPM. So RPM is revolution per minute. So step on the gas, that goes from 1, 2, 3, 4, 5, 6, 7, 8, and then you reach to the red line, right? So they said 1 times 1,000, so that means 1,000 RPM. 2 is 2,000 RPM, and then the ring on the right is the speed. So usually in the US, they use miles per hour. In Canada, they use kilometers per hour. So let's back to the US. So in US, we use miles per hour or mph. So when you drive in the city, you drive 25 miles per hour, 20 miles per hour, 30 miles per hour, maybe on expressway. When you drive on freeway, 60 miles per hour. So the 25 mph, the 30, the 65 miles per hour describes your speed. So you are driving at a highway right now, your current speed is 65 miles per hour. That is your speed. So look at the ring for the mph again. So the lowest number is 0. So when speed is equals to 0, then you are not moving. You turn the car off, you turn the engine off, then the line back to a 0 mph. That means you are not moving at all, right? So when the mph is greater than 0, then the car is moving. Can miles per hour be negative? The answer is no. So for the miles per hour, either it is positive, your car is moving, or 0, your car is motionless, not moving, or it cannot be negative. There is no negative mph. Check out the two rings. Do you see any negative value? Check the entire dashboard. Do you see any negative values? No, right? Because speed cannot be negative. So now, one conclusion that we make right now is speed is either 0 or positive. The minimum is 0, and then the maximum, depending what you are talking about, right? So if your speed is 0, that means you are not running at all. If your speed is positive, that means you are running. So how about velocity? Velocity is based or is similar to speed, not exactly the same, but you need to define directions. So moving on to velocity. So for velocity has direction. You have to define direction. So let's say left and right, an object moving to the left has negative velocity, and object moving to the right has positive velocity. It can be moving upward, positive velocity, moving downward, negative velocity. Okay, so let's do an example. So let's say we have a 6 feet tall man throws a ball upward into the air. The following data is obtained. So we have the t. The t means time. The time is measured in seconds. So 0 seconds initially, the ball is 6 feet off the ground, right? And then 1 second later, that is 60 feet off the ground. 2 seconds later, 132 feet. 3 seconds later, 160. 4 seconds later, 190 feet, and then 5 seconds later, 170. So looks like after the 4th seconds, the ball stopped falling down to the ground, right? Now, my question is, how do you define the direction? So let's define direction. So give me a picture. So let's say this is ground, So this is ground. And then 6 feet tall. So we start at this point, right? So the ball is right here, 6 feet off the ground, and then throws into the air upward, right? So the ball will go up and then reach to the all the way to the top and then drop back down like that. So here is how we do the define. So that when the ball goes up, the velocity is positive. When the ball drops down, the velocity is negative. Okay. Now, how about average velocity? So for average velocity, I have to give you a formula. So for average, let's do this in a different color. So for average velocity, that is equals to change of position over change of time equals to change of position divided by change of time. That requires an interval. So you have to tell me interval. So let's say the time interval. T is between when and when. So T is between time A and time B. Okay, so that is equals to, and then the formula works just like the slope of a straight line, rise over runs, like y2 minus y1 divided by s2 minus s1. So B minus A, finish minus start, and then S of B minus S of A. S of B minus S of A. Just like y2 minus y1 divided by x2 minus x1. So let's do a quick example. So let's say I want to calculate the average velocity from time 0, from 0 seconds to 3 seconds. So let's say I want to calculate average velocity. The time interval is between 0 and 3. So the way we do this is, so this is A and then this is B. The denominator is 3 minus 0. When time is equals to 0, the ball is 6 feet off the ground. When time is equals to 3, the ball is 160 feet off the ground. So we have 60 divided by 3. So that is approximately equals to 51.33 feet per second. So this is a positive. So this is a positive. That means the ball is during this interval, the ball is going upward. Positive velocity, the ball is going upward. Let's do one more. How about the average velocity between the 5th second and the 7th second? So average velocity, AVG, right? So AVG velocity, the time interval is between, let's say, 5 and 7. So this will be a 7 minus 5, right? And then what about the top? When x is equals to, I should say when t is equals to 7, we have y equals to 20. So we have 20. When t is equals to 5, the ball is 170 feet off the ground, and then you minus 170. And then you do the math, that is a negative 150 divided by 2, then you have a negative 75 feet per second. So this average velocity is negative velocity, and then that means the ball is going downward. And then one thing that I have to remind you is when you write your answer, you have to write the number and the unit. So the unit is important. So in this type of problem, unit is important. So let's say, let me tell you how important the unit is. So let's say you pay $6 to buy 4 mangoes. What's the unit price? The unit price on average, so average, you take $6, right? So $6 divided by 4 mangoes. Do you see that I did not write 6 divided by 4, I write $6 divided by 4 mangoes. So that is equals to $1.5 per mango. If you just say 1.5, then I will ask you 1.5 what? You have to tell me $1.5 per mango. So when you pay for gas, you pay $4 per gallon, right? You pay $3.50 per gallon. So we have the dollar on top and the mango on the bottom. So that's why this is a dollar per mango. You don't do 1.5 mango per dollar. You never heard of that, right? You never heard of 4 gallons per dollar. You never heard of it, right? So back to our average velocity. What do we have on top? So the top, the 160 minus 6, this is in feet, and then this is in seconds. So therefore, the unit is feet per second. Feet divided by second. All right, so clear, right? Okay, moving on to the next thing. So the next thing we have, the next thing I would like to do another example. So let's say a particle is moving along the x-axis as a function of time in second, and then x is in meter. Okay, so this time we have some negative values. Okay, let me ask you some questions. So the first question is, what is the average velocity between 0 times 0 and 6? So what is the average velocity? So average velocity, the time interval is between 0 and 6. So time is between 0 and 6. What do? At the end of the day, you have what? What's the unit? This is in meter, right? So you should have meter per second. So that means you put the meters on top and then the seconds on the bottom. Meters per second. There is no second per meter. So meters per second. So we subtract the time in the denominator, then 6 minus 0. So when x is equals to 6, the meter is -2. When x is equals to 0, the meter is -4. You subtract a -4. So that becomes a -2 plus 4, that is equals to 2. And then divided by 6, that is equals to 1/3 meters per second. Okay, so this is positive. Positive means you have to define this. If positive is moving to the right, then positive average velocity is moving to the right, then negative average velocity is moving to the left. You have to define the direction. And then average velocity, let's do one more. So let's say the time is between, how about 4 and 10? Again, the unit is in meters per second, so you have meters on top and seconds on the bottom. Then this is a 10 minus 4. When t is equals to 10, we have a -4. When t is equals to 4, right here, we have an 8. So that is a -4 minus 8, which is equals to -12. And then this is a 6. -12 divided by 6 is equals to -2 meters per second. All right, so that works just like the slope of a straight line. So that works just like slope of a straight line. So slope of a straight line. So slope of a straight line, you have a straight line, right? So this is one point, this is another point. What's the slope? This is x1, y1, and then this is x2, y2, and then the slope is rise over run, so which is y2 minus y1 divided by x2 minus x1. This is called rise over run. Okay, so we need this idea for the next problem, so that in the next problem, I recall the data for the 6 feet tall man problem. I recall that data. So this is the data that we just used. Okay, so what we are going to do next is I am trying to ask you to give me a graphical representation of average velocity. The time is between 0 and 3. So what I want you to do now is I want you to calculate the average velocity. The time interval is between 0 and 3, and then you can just go back to your notes and then copy it over. So that is equals to what? That is equals to the time 3 minus 0. When t is equals to 3, we have 160. When t is equals to 0, we have a 6. So overall, we have a 154 divided by 3. That is approximately equals to 51.33 feet per second. Okay, so using the graph, we will have to use what we just discussed, the slope of a straight line. When x is equals to 0, we have a point right over here. When x is equals to 3, we have a point right over here. I have to let you know that the scale is not perfect in here. Just consider that as a curve. Between 0 and 3, we are going to sketch a straight line. Sketch a straight line between 0 and 3. Now, my question is, what is the slope of this straight line? And then you will use the rise over run, right? So this is the run, and then this is the rise. So how do you calculate the run? The run, you use bigger x minus smaller x, 3 minus 0, that is equals to 0. And then how about the rise? Big X minus small x, so the rise is equals to bigger x, which is 160, minus the smaller x, this is 160, right? And then this is a 6 minus 6, that is equals to 154. And then the slope is rise over run, so which is 154. Why do I put a 0? Divided by 3, so that is approximately equals to 51.33, which is the slope of a straight line. Slope of a straight line. So positive average velocity increasing, negative velocity is going downhill. Now, what happened when the slope is downhill? So what happened when the slope is downhill? I don't want to use this piece. Because the scale is not good. I will just go ahead and then draw another piece for you. So I will just draw a parabola that looks like this, and then maybe not that one here. Yep, perfect. So let's say from point A to point B, what is the average velocity? So what you have to do is you draw a straight line to connect them, and then this is rise, and then this is run. So this is rise, and then this is run. This is from A to B, right? This is from A to B. And then for rise over run, we have the run is B minus A, bigger X minus smaller X, and then the rise is bigger. The rise is the big Y minus the small y, which is S of B minus S of A. Oh, actually, this is smaller. This is bigger. So as a result, you will get a negative on top and a positive on the bottom. And then therefore, you will have a negative slope, which is negative average velocity. So back to the beginning of this video, do you still remember the question? Back to the beginning, I asked what was your velocity? What was your instantaneous velocity at the moment you cross the finish line? So at the moment you cross a finish line, we can use this graph one more time. What was the slope at this point? I am not using 2 points anymore. I am using exactly 1 point. What was the slope at this point? If you have 1 point only, and then you sketch a straight line, and then this will be your straight line. Well, since you only have 1 point, then the rise over run is not going to work, because in order to apply the rise over run formula, we need 2 points. If I am asking for the velocity at 1 point, at one specific point, what we just did in orange is I use 2 points. I use average between point 1 and point A and point B. Between point A and point B, there are many data, right? Between point A and point B, between 0 and 3, there are so many points on the curve. I am asking for an average. But in the last problem, I am asking for 1 point. At that time, can you tell me what the slope is or what the velocity is at that time? Well, the rise over run formula is not going to work. We need to work it out to reach to another formula. I will discuss that in the next video, so stay tuned. I will meet you all over there.